The first thing I want to draw attention to is a document entitled Water Fuel Injection System, Memo WFC 423DA. This is definitely one of the more important documents pertaining to the water fuel cell technology of Stanley Meyer's. There are several images in this document which can help us to better understand how the technology works. In particular, one image on page 15 entitled Figure 4-5 Voltage Triggering. This is probably one of the most significant images in all of the literature, mainly because it shows that in the Meyer's dune buggy, within the water injector itself, that would be within the piston of the dune buggy, which was a regular internal combustion engine, according to Stan Meyer's. He wasn't just burning gas within that piston through a special spark plug. He was fracturing the water within the piston. And he wasn't just fracturing water. If you look closely, there are 3 chambers with inlet ports. 1 chamber for water, 1 for ionized gases, and 1 for non-combustible gases. Now in the literature, he explains how these 3 components are mixed under pressure so that they form one homogeneous substance, which is then injected into the voltage field, where it is separated first into hydrogen and oxygen, and then detonated. Now, what is the most significant thing about that? Water expands 1,800 times when it is fractured into hydrogen and oxygen. That means that most of the energy used to drive the piston comes from the fracturing of water into the gas, instead of just the explosion. That's why many scientists would say, oh, it would never work. You'd need a huge amount of hydrogen gas that could never be provided on demand. What they didn't understand is that the hydrogen gas wasn't the only thing running the piston. Not only that, I'm sure he made it so that there was a little bit extra water, so the heat from the resulting secondary explosion would drive the water into steam, and not just any steam, but superheated steam. When the hydrogen and oxygen recombine, the resulting water vapor that's created is typically in a range of 275 degrees to 300 degrees Fahrenheit. But given the high pressure conditions that can exist in the cylinder, that temperature could be much higher than 275 degrees. Now, this schematic is oversimplified. It is just a description of the general arrangement within the piston. It's not the exact schematic, it's not the exact components. It just shows you the general concept of the actual water injector. Another really important thing that we have to understand is that the ionized gas plays a critical role in the fracturing of water, in that it absorbs the ejected electrons from the water fuel mixture. In other words, when the water itself that's being injected into the cylinder is subjected to the high voltage field, the oxygen molecule will eject electrons, which will then flood the fuel injector. So what Meyer's has done is he's incorporated the introduction of ionized gas, positively ionized gas, into the injector with the now positively ionized water in order to capture those ejected electrons. Because the ionized ambient gas will now have a positive charge because it's missing electrons, which have been stripped away in the air processor. It will attract the electrons that were ejected from the water molecule and preserve the excited state of the water fuel mixture, which is one of the key factors in the efficiency of the Meyer's voltage intensifier circuit. When water hits the voltage fields of the plates, which are basically a positive and negative terminal within the spark plug itself, the water is ionized. It's not split. It's not using current to split water. It is using a high voltage field to ionize the individual hydrogen and oxygen atoms of the water molecule. And this is a basic process of all lasers, in fact. And when you really think about it, Stan Meyer's device is essentially a water laser, or a water lasing device, which wouldn't be a laser with an L. I don't know what you'd call it. But it works on the same principle, except that instead of yielding light, it yields heat and gas vapor. And that's the most incredible thing. So, I mean, at the most rudimentary level, you're getting the fracturing of water into the component gases, which is an 1,800 times increase in volume. And in addition to that, it's also creating a thermal explosion, which, because of the addition of the non-combustible gases, becomes explosive. Normally, if the ratio of hydrogen to oxygen is the same as the ratio of 2 hydrogen atoms to 1 oxygen atom, the resulting detonation will have an implosive character to it. But because of the introduction of the non-combustible gas, the ratio is interfered with and is thrown off, so that the gas isn't allowed to implode, so it explodes. So the ambient air mixed with the non-combustible gases, which I believe to be actual water vapor, which was reintroduced into the piston from the exhaust of the previous detonation, that's probably condensed water. It's probably a water, not a water vapor in a sense of steam, but a water vapor in a sense of particulate water. So maybe it is just below the boiling point when it reaches the actual chamber for detonation, and it becomes explosive, heating the air, which was also introduced into the piston, heating the ambient air and causing the air to expand, and thus giving even more thrust to the piston. Now, the resulting heat from this detonation would also cause the remaining water mist within the injector to be exposed to a super high heat caused by the detonation of the hydrogen, so that that water, number one, it would be changed into steam, performing the action of a steam engine inside of the piston. And number two, if the temperature of the hydrogen detonation exceeds, I believe, 1,500 degrees, then the water, in addition to turning into steam, will also fracture again into hydrogen and oxygen and yield another 1,800 times increase in volume, further pushing the piston. So I believe it was a combination of all these factors which enabled the water fuel injector to use such a small amount of water and get such an enormous amount of pressure within the cylinder. I know it's explained that it all happened separately, but the device makes it all happen so quickly as if it just happened in an instant, which is why Stanley always said to instantly release the thermal explosive energy in water.